Welcome everybody to the NVIDIA Omniverse live stream. I'm very excited for this one today. We have a very talented group of developers we're going to be speaking with, and we're going to touch on OpenUSD, Python, robotics, Arduino. Super exciting topic today. Before we dig in, some couple of quick announcements, including this on the screen right now. Computex is just days away now, June 2nd. You can check out the keynote from Jensen at 7 p.m. Taiwan time. And if you're curious, I believe that's 4 a.m. Pacific, but you'll be able to watch it afterwards on demand, of course. Should be very exciting. There's going to be lots of great announcements coming. We'll post a link to that in the chat. Amelia are great producers in the wings helping with all that. So feel free to ask your questions and we'll do our best to keep up in real time. And then obviously a recent discussion we had with the Continental and Soft Serve team. We've got a great blog post on their great collaborative work leveraging OpenUSD. And we on this live stream a few weeks ago touched on a lot of things, but a lot of it was focused on interoperability and how OpenUSD made it all possible. The live stream is a great complementary kind of resource in conjunction with the blog. So I would check out both. We'll post a link for both in the chat. And those folks are actually very accessible. So if you have any questions, let me know in the Discord server, which is discord.gg/NVIDIA Omniverse. And I'm happy to put you in touch. All of our OpenUSD training labs are now available on demand. This is just from the recent GTC. So feel free to go grab that free content. And then we also have all the GTC session replays are currently available as well. So there's lots of great learnings there. If you missed it GTC or you didn't get to see it all, now is your chance to catch all that great content. And then I think the guest tonight now is standing in the wings. Let me bring them in. Here we go. Hey, Jack, Jamari, there's Sam, and Rebecca. Look at this all-star crew. So today we have a very exciting topic. We're jumping into a real-time robot arm simulation with Arduino and OpenUSD. And this is all made possible through a pretty fantastic program that Sam's here to tell us more about and was actually introduced to us by a great Omniverse user from the community that a lot of people will know from his presence here on previous live streams and also a great blog post on his work with accessibility and OpenUSD. And that is, of course, Professor Matthew Schwartz, who may or may not pop in at a certain point in the live stream. We'll see if we can pull him out from the wings. But Sam, thank you so much for joining us today. Why don't we do this really quick? I'll do a quick round of introductions, and then we'll circle back to Sam to give a full overview of this program I'm referencing. Let's start with Jack. Hey, welcome to the live stream, Jack. Let us know a little bit about your background and what you did on this project.
Sure thing, Edmar. Well, everybody, I'm Jack. I'm a third year going into my fourth year mechanical engineering student at NJIT. And for this project, I worked on the physical robot, making sure that we had something to test in the physical realm. So involved working with an Arduino, a servo motor, 3D printing some components, and eventually kind of just putting them all together to get the little robot we have. So yeah.
Awesome. Yeah, and if all that stuff piqued your interest, sit tight. We're going to be showing a lot of that stuff that Jack just touched on in a few minutes. Really fantastic. Okay, that's Jamari. Welcome to the show.
Hello, everyone. So my name is Jamari Adames. I'm a recent graduate of NJIT. I studied industrial design. And for this project, I basically just focused on the simulation and bringing everything together in NVIDIA Omniverse.
I'm so happy to have you here. And Rebecca?
Hello, my name is Rebecca. I am also a recent graduate of NJIT. I also studied industrial design, and I did the coding and some of the hardware for our project. So very excited.
Amazing. Super impressive work. And last, definitely not least, Sam.
Hey everyone, I'm Sam Gatley. I'm the director of the COMET Center. It's an advanced manufacturing workforce development center that NJIT, the New Jersey Institute of Technology, that these three are students of, and NJI, the New Jersey Innovation Institute, our kind of business-facing, government-facing wing, stood up to give students a little bit more hands-on experience.
That's amazing. Yeah, and it's when Matthew Schwartz was telling me about this program and what the type of work that was going on, I was extremely impressed. And I was checking out the website, and I think we have a nice video here. Maybe you can walk us through going into more details.
Absolutely.
All right, so let's play this video, and then I believe y'all be able to speak over it. Let me see. Here we go.
So the fun thing about the video and the website is that we're moving so fast they're a little bit out of date, but this is some footage of the 20,000 square foot facility we have. We do advanced manufacturing, but kind of the core is really additive manufacturing. So we have some metal printers. Since this was captured, we actually also got a Philips Hybrid and a Speed 3D Warp Speed that are both really amazing cutting edge machines. We do plastic 3D printing. So we've got some of these consumer level printers, but you'll also see we have some really nice industrial scale printers, as well as electronic 3D printers. It's a part of the industry that even people in 3D printing don't really know about. Tie it in with robotics, and the students here will tell you a lot more about the work we do there. But a lot of what we do is also supporting small businesses, developing prototypes and MVPs so they can go after more funding and kind of get their feet underneath themselves. The workforce development effort that we have, like I said, is getting hands-on experience. These students come to us with really good foundational skills, but they've never worked on an interdisciplinary team. Right? We have 2 industrial designers and a mechie here. We also had computer science, electrical engineering, all sorts of fields that are how industry really makes amazing products. But in university, you only have 4 years and so much time, so you don't usually get that sort of experience until you're on the job. So we try to do a little bit more of that, make sure that we have real world problems to work on. So we engage with industry. So I'm not just making up stuff. The students are actually developing skills that are immediately in demand. And digital twins of everything we're making, from the machines we're operating on, the space we're operating in, to the actual products that we're producing, are of extreme interest. And so that's kind of how Matt connected us to Edmar and the team here.
Absolutely amazing. What a fantastic place to work out of and collaborate. So it looks like the school of tomorrow today, but it looks like a combination of also very high tech makerspace and kind of a factory of the future as well. How many people are typically working out of there? How many students?
Yeah, so we've actually got a cohort of 20 new interns starting next Monday, June 3rd. We've got, I think we're up to about 10 from last summer that I just couldn't let go of yet. A number of them have already transitioned to full-time staff members. We develop a workforce for the local economy and small businesses, but also for ourselves. 2 of my staff members who helped me get this place started were interns back in 2018. And so, I kind of turned the workforce development in on itself. For a while there, it was just a scrappy team of the 3 of us, but we're up to about 10 people, and we've got a lot of machinery and not enough people to run it. So looking to hire.
What a fantastic program! Really exciting. If you're just joining us live now, feel free to put your comments and questions in the chat. We are chatting with a group of students and the director of NJIT's COMET Center. We're going to dive into their robot arm simulation work in Omniverse in just another minute or so. So this is kind of a mix of different topics, including digital twins, which you'll see in a second. So really excited to get this party started with the students, or should I say, mostly former students, and one current student. Jack is almost done. And we actually have everybody's LinkedIn links as well. So Amelia, our producer, will be posting those links in the chat. If you want to get in touch with any of these great developers, feel free to reach out to them directly. Okay, so let's dive in and talk about like the overview of the project. And I think we've got a nice little slide here. Here we go. Okay, so let's talk about the actual project. Before we touch on what you guys did, can you tell me a little bit about why you guys kind of dived into this?
Yes, of course. So as students that are just starting out in the workforce, we were very excited about exploring the technology of digital twins and how it could be applied to like real world scenarios, and also get a head start and get prepared for the future of manufacturing and also design research and development. So we thought making a little robot arm and a little simulation would have been a really fun way to do that.
I'm sure that. Go ahead, Jamari.
Sorry. Yeah, we could just go to the next slide.
Yeah. Oh, so here's the team,
Yeah.
and here's the workflow. Okay, cool. All right. So, wow. So a lot of really cool touch points here. Speaking of workflow. All right. So who's going to walk us through this?
I'll continue walking us through this. So basically how our project works, or how our robot digital twin works, is that we start out with a controller and sensors that are receiving data, analog data, that is output into an Arduino. And the Arduino is sending out signal to both the physical robot and our digital twin within Omniverse, and into that scene. So the scene is actually has a Python script attached to it that is able to control different assets, such as our URGF that we imported from Fusion 360 of our robot, which had attributes that is updated with a Python script during real time. That's essentially how it works. Okay,
Very
go to
cool.
the next slide. So yeah, this is just pictures of our robot, our physical robot. We actually have a 3D printer that uses pellets to melt it and then extrude it. So we thought it would be a fun idea to use a little bucket for the robot arm that could scoop out pellets. But yeah, it was a cool concept. And now I'll pass it over. All right. You had a question?
Yeah, well, actually, let me say, because I know there's going to be people watching this right now that are just to give them a little bit of a nice surprise. Everything you're watching now, the team is releasing their code on GitHub. So we're going to post a link in the chat so you can actually dive into and look at the work that they did right on GitHub, which is fantastic. So Jack, so take it away.
Yeah, so if we go to the next slide, it kind of shows a, oh yeah, here's the demo video. You might want to pull that up.
Okay, so this is going to show, let me see, this is with the hand, right?
That would be correct, yeah.
All right, here we go. Okay,
yeah, so what we're
ahead.
seeing in this video is we've got the actual digital twin running with the real robot and the controller all at the same time. So as you can see, it did a little bit of a splash there in the container, but real-time physics simulation acting at the same time as our real world. So pretty cool.
That's very cool. And then we have another view of that, I think, from the SimPure side. Let me show that really quick.
So I just want to jump in real quick and say, when I first saw that, my mind was blown because I didn't realize they built a digital twin of the space as well. So I thought I was watching maybe just a live video of the robot reflected on a monitor. And then the closer I looked, I saw some incongruity. But I mean, it is some cool work they've done, I must say.
It's totally cool. All right, let me watch this. Here's the full sim. Very cool. So this is the environment they created. Yeah, the first time I saw this, I thought this was the real video. Until that kind of gave it away a little bit. Very cool. This is wild. And if I remember, you guys actually had created this robot arm from a previous project, right?
Yeah, so this actual robot arm is not ours. The GitHub for it is in a link that we can put down in the description or whatever, but essentially we're building off of this platform to kind of use for the digital twin.
Amazing.
All
Very
right.
cool.
Yeah, so the physical start of this robot, I was having a conversation with Professor Schwartz, and I was telling him about this idea of a robot Zen garden. As you can see with this ChatGPT generated image, maybe a little bit not the way it should be looking, but at the end of the day, it kind of gets the point across. I wanted to have a robot arm, kind of just be able to take care of a Zen garden, whether it be controlled by a person, whatever. But getting to that idea and figuring out how to do it, I was having some problems. So in that conversation, I was able to talk to Professor Schwartz, and he told me that being able to simulate the robot in Omniverse or some other type of simulation platform would give us a better idea of how to design the system and then also how to integrate it as well, and look for problems and see if the idea was even worth it.
What a smart guy that Professor Schwartz you've got there.
Certainly a smart guy, yeah.
Very cool. Okay, so this is how it kind of got started, and then what you did next.
Yeah, so in the next slide, it shows a little bit of the actual foundation building this thing up. On the left-hand side, there's just kind of the preliminary of what we had. This is and the bottom you see a breadboard there. That breadboard has the 4 potentiometers that end up we use as controller. In a high level, we take the potentiometers and we take out their analog signals, and those analog signals are then transformed to go to a PWM signal that can then control the motors. So this little controller on the right, this little cute guy with a little handle, this is actually a 1-to-1 scale of the bigger robot. And if we go to the next slide, you can get some more information on that. This is the wiring diagram for it. So a little more easy to digest if you're used to these type of things. We've got the potentiometers on the side with their analog signals, and those go to our Arduino Nano. Then that is set up with a Wi-Fi connection. So in this one here, we have kind of a showing of what those components are actually doing. So on the left-hand side in the blue is the servo motors, and those are in the larger robot. Those are the things actually making the robot move. But then for the controller, we're using the potentiometers. So on the purple square there. And as you can see, those look very similar. It's because all the geometries are the same, so that when you move the little robot arm, it moves the bigger one exactly as it needs to be. So
that's great. So
sweet.
Cool.
Yeah.
So once we kind of had that robot arm working, we were able to reconfigure some of the hardware to work for this new digital twin project that we were working on. So part of what I was doing was reconfiguring the circuit to work with a different Arduino. So we use the Arduino Nano RP2040 Connect, which has Wi-Fi connection capabilities. And that was really good for our wireless streaming of all of the input data that we were getting. And another really cool thing that we have here at COMET is the ability to make our own custom PCBs and printed electronics. So I had worked with another team member here, and I gave him like the most awful napkin sketch of the circuit that I was planning. And he was able to use the LPKF Proto Laser U4 that we have here. And he was able to print this reconfigured circuit that you see on the all the way on the right. And then with that, I was able to set up more of the hardware. So this is kind of the finished circuit with everything soldered on. And I have some experience with soldering and electronics, but this was really exciting to me. It was the first time that I kind of saw this circuit come to life. And once we had plugged in, the new Arduino, I started reconfiguring some of the code. So this is the code that gets uploaded directly onto the Arduino. And it starts off, it's just got some simple setups with the different potentiometers that are coming in. And then it sets up a UDP Wi-Fi connection. So it sets up a little socket and then starts streaming some of the data. And that's all based on our network. So if anybody's trying to recreate this at home, just make sure to put in your own network information. But it takes in all of the analog data from the potentiometers, and it kind of sends it out to 2 different places. So it'll send it out over the Wi-Fi, and that'll end up going to the Omniverse digital twin, and then it sends it to the servo motors, which then controls the physical robot as well. So this code just kind of shows the back end of all the magic.
That's great. So cool. And how long did it take you to do the coding part of this?
Well, I'm not super great with coding. I'm relatively new to it. So I was able to find some code from community members online and kind of add my own information in there. So overall, I'd say with all the learning curves and everything, it took me maybe like a week total of just trying to get it to work and debugging and, all that. But I was also able... Oh, thank you. I was also able to set up the behavior script. So this is done with Python now. And this is what gets connected directly to our digital twin. So the Arduino code sends out all of our controller information. And then the Python code actually applies that to our digital model. So again, it's just setting up the connection with our network, making sure that it's receiving the correct data. So the Arduino code sends to a specific network, and then our computer is connected to that network, so it's looking for that information. And then it takes all that data and it kind of moves some of the numbers around just to make it work with our model. And then it applies the specific data points to each of the joints in the model, which then allows it to move as, you know, all those values are changing.
Fantastic.
So, yeah.
We have a quick question here, actually, that might be timely. I'll put it on the screen. Was the debugging done using the digital twin?
Yes, for the most part. A lot of it, I was working with the Arduino and sending data and just kind of seeing whether or not it'll show up on my other computer. A lot of the debugging did come with connecting it to the digital twin, trying to move around some of the joints, seeing what the problem was. So that was definitely a little bit of a learning curve, but I've only ever used Omniverse for like rendering before. So this was actually a really fun challenge for me.
That's great.
And I'm pretty proud of the outcome. So
Yeah, you should be. This is really fantastic. And I can't thank you all enough for just walking through every step here. I think this is so valuable and inspirational too to all the developers out there who are experienced. We definitely have a lot of robotics aficionados in the crowd, but also new developers who are just kind of diving in. And as Rebecca was saying, you know, she doesn't consider herself a veteran coder, but she was able to do all this work. Really, really cool stuff.
Edmar, if you don't mind, I'd like to address Sanzo's comment or Sazno's
Oh,
comment.
yeah. Let me put it on the screen. Here we go. Can you tell us about modeling the robot arm and rigging it with joints?
Sure. So I can't talk about everything about what goes on to modeling it, but I can tell you that we used a URDF exporter that was in Fusion that was made by Professor Schwartz. And using it, we were able to get things like the inertia properties, the joint positions, the collision meshes and stuff like that that are generated from that. So essentially, you can take your Fusion 360 workflow and then attach it to with this descriptor that'll then go and work in Omniverse. And that is how we were able to get those models in.
Very cool. Great question and great answer. Okay, so let me see. What is the next slide here you have?
Okay, so I think the best part of this entire project was seeing everything come together in Omniverse and in OpenUSD. So if we go to the next slide.
I think it's coming. There you go.
Okay, yeah. So the first step in this process was actually having the joints added in Fusion 360, like Jack said, making sure the limits were properly working, doing motion studies, and then I was able to use the URDF exporter extension. And if you go to the next slide, we could show how they were imported into USD, making sure the limits were set. And also all of the joints came in through. So one thing that I did learn was just making sure the scaling was the same while bringing it in, and also like the units was the same as well. And it worked properly. So it was pretty cool to see.
Amazing. And so how difficult, we have a good question here. How difficult was it learning Fusion 360 first?
Actually, like I've used Fusion 360 for modeling most of my career during my studies at NJIT. So it was relatively simple to understand. I think that's why I also decided to do the joints in Fusion 360. And yeah, was able to import it like very easily from using the URDF exporter.
Very cool. I mean, there's a lot of people watching live right now. I see the numbers keep shooting up, so you guys really got everybody interested. Including this, we have this great comment here. I'm currently working on a similar project using Blender and Raspberry. Did you use Isaac Ross to establish communication? You guys didn't use Ross, right?
No, we didn't. So it was actually using Fusion was easier for us, like Jomari had said, because we've been using it in like our classes and studies and that sort of thing. And the URDF exporter was just like the easiest for us. In terms of like learning Fusion, I know for me, like we had started using SolidWorks and Fusion was a little bit easier on the eyes and a little bit easier to manipulate. But yeah, we definitely didn't use ROS for this.
Very cool. Yeah, well, as people will see, there's lots of different ways to go about achieving the results. So it's really cool to see how you guys went about it, and especially in the interest of time available time you guys had too, because it was basically a team of 3, right? Or you worked with one other developer. You had 4 altogether, or 3? The 3 of you.
So
It was
the 3 of us kind of did a lot of the main work, but we did have a lot of other people, team members and coworkers here that helped us with some of the other steps along the way too. So.
Yeah, so I plugged it in the beginning, but one of the big things we like to do at COMET is bring together complementary skill sets. I think in college you hear a lot about teamwork and how important that's going to be. And then oftentimes in classes, it's kind of arbitrarily sliced up with similar people at similar points in their career working on the same sort of stuff in their major. We bring together mechanical engineers, industrial designers. The digital twin of the space was actually done by a recent interior design major. And so, they bring to bear unique skills. Computer scientists, we have an electrical engineer who helped out with the LPKF. And together, they're able to do this really impressive work a lot faster than if they had to kind of learn those skills on their own from square one.
That is amazing, and I couldn't agree more. It's so great to see all these interdisciplinary backgrounds come together and build this project. So, for Jack and Rebecca and Jamari, is this the first kind of team project you guys had worked on in the program, or you guys had done this kind of before?
I think a lot of what we did last summer was all about collaboration. So we definitely were teamed up a lot of the time to make projects, and also switching around the teams to see different results as well. And like learn
cool.
different things from different people.
Yeah. That's amazing. I think it's such a great way to work together, and that's one of the great kind of benefits of OpenUSD, in that you can have people who are leveraging different applications and software, and if they're using OpenUSD, they can kind of transfer that data very seamlessly back and forth. So that's also awesome. How did you all find working with OpenUSD, since this was probably, I'm assuming, your first project working with OpenUSD and Omniverse? What was your kind of how'd you learn? How'd you get started first?
So I had gone through a lot of the getting started documentation from, NVIDIA and all that. So I did a couple tutorials, kind of got a handle on some of the layout of everything, but a lot of it was just kind of bulldozing through and figuring things out as I went, which I found, pretty enjoyable. So yeah, trial by fire, I guess.
Yeah, that's great. That's a great way to learn. I know a lot of people in the community do the same thing. What about you, Jack and Jamari?
Yeah, I think I started enjoying it more when I just started doing it by myself and just doing things. And if it didn't work, it didn't work. If it did, it did. But yeah, I definitely learned more that way. I also started with the tutorials as well with Rebecca, just to get like a general understanding.
Very cool.
I would say, honestly, for me, the examples helped a lot. So I believe it's 4.1 through 4.4 are a really solid foundation for like robotics applications in Isaac Sim with like OpenUSD. And that ended up being very helpful for me getting into that.
Very cool. And look, we have our first soundbite from Zia here. Bulldozing is the key. We have a good question, actually. Here's from Zia. We have a good question. How closely was the team able to model the physics of the joints moving in the real robot arm versus the sim? It looked pretty close. Who wants to take that?
So for that part, in order to make it look like as close as possible to the actual physical model, I realized like changing the mass of it and also the force applied to the joints really helped. yeah, to make it look a lot similar to the physical model.
Very cool. Fantastic. Okay, cool. So are we moving on from the current slide?
Yeah, can go to the next slide. Okay, yeah, so the next step in the process of simulating everything together was to just familiarize myself with making a particle scene. So I used one of NVIDIA's sim-ready assets, which was the room depicted in this picture. So yeah, at first I just used the existing particle system to just figure out like how to change it in order to apply it to what we needed it to do. If we go to the next slide. Yeah, so I actually found once I imported the robot into the scene, since scaling was different than the scene itself, it kind of messed up some of the joints. So I found it easier to just have the robot working and then making my own particle from scratch in the robot scene. So that's what I did. And then if you go to the next slide. Also, I found that changing values such as like the contact offset, the rest offset, and like how those affect one another was an interesting learning curve. But I figured out how to like make the particles smaller. Also, like if I make it fluid versus non-fluid, how the particles would react. And I found the particle system very interesting because this is not something you're able to predict, simulate just from a regular digital twin. So being able to apply the physics to be able to predict how the particles are moving in the real world is pretty interesting to me. And then we can go to the next slide. Yeah, and this is just how we ended up. This was the finished result for the particles. I tried to mimic the pellets as close to as possible as I could. And next slide. So after we had the particles interacting with the robot, the next step was to replicate our environment as much as we could. So for that, we actually had an interior designer on the team, Cindy Pisa, and she was able to use an existing 3D model of our building and just import some assets and also use some assets from NVIDIA, such as the computers, to bring everything together and make it look as close to as possible as the real one.
That looks pretty close. That's pretty awesome.
I think she did a really great job.
I agree.
And the next
awesome.
slide. And then finally, to finish bringing everything together, the final step was just attaching the Python scripting that Rebecca was working on. And that was it. So once that's applied, we were able to just simulate everything on real time. And yeah, we could probably play the video again of our demo so you guys could take a look at it again.
Okay, cool. Let's take a look at that final video, and then I got a couple of questions too that are really good ones. Right, here we go. Take a look at the final work. Whose hand is that? I forget. I asked you guys the other day. I can't remember.
Yeah, that's Sydney. She was someone that was helping with integration on our team as well.
Well, thank you for being such a great hand model in this example. Yeah, very cool. Yeah, it's wild. Okay, we have a couple of great questions here. Let me see. So how did you get the Arduino to communicate USD composer behavior scripts? Who worked on that part?
That was me. So the whole thing runs off of a UDP connection. So it was really the Arduino that we used. It already has Wi-Fi connectivity incorporated in that. So it was just setting up, making sure that the data is streaming to the correct network, and then having your whatever computer is running everything, like the Python scripts and everything on Omniverse, as long as that's connected to the same network, it'll kind of like identify and bring in that information that's coming in.
Great information. Let me see. I think we have another comment here. Here we go. What was the difficult part when you connect the wireless with Omniverse Python code?
So I think mostly it's just making sure that you're set up on the same network. I mean, the code that I have that's available on the GitHub, if you want to take a look at that. I don't know if it's up yet, but we're definitely working on bringing everything over. Yeah, I mean, there's a lot of like prints and serial reads and that sort of thing that kind of tell you the status of whether or not your Arduino is connected and whether or not it's actually beginning to send anything or if it's waiting for a connection. So there's space to put like the network name and the password if it's password protected. And yeah, for the most part, it's pretty straightforward, but just, double checking all your work and connections is definitely important.
Very
Yeah,
cool.
there
And
was a lot of times where we would be freaking out, like, why isn't it working? And it was the Wi-Fi. We weren't connected to it. So, yeah.
it's always the Wi-Fi. And then we got a good question here, somewhat related. Did the team detect any lag or latency between the real and sim?
Definitely a little bit. We were working with some pretty slow computers at first, which was adding to that a bit. But using the UDP connection, it's like really small packages getting sent over. So for the most part, I found it pretty like in sync, which was really cool.
I think we actually had a really funny moment where they were showing me their demo, and at the time it had a good half second of lag, and I thought to myself, like, oh, that's cool, but there's a little bit of an issue here. And I asked the team, and Jack went back in the code and realized he inserted a half second delay to kind of help with troubleshooting along the way. And so as soon as he took it out, I mean, I assume there's some milliseconds of latency, but it looks pretty darn real time.
That's wild. That's awesome. We have hundreds of people watching right now, actually. So welcome to all the viewers out there. If you find this kind of content discussion helpful, don't forget to like and subscribe. We've got a lot of great Omniverse content on these live streams every week. If you're just joining us, we are joined with a group of graduate students and current student at New Jersey NJIT's COMET Center. They're demonstrating their robot arm simulation in Omniverse, where we've been touching on Arduino, Python, OpenUSD, digital twins, you name it. This is pretty much hits all the main buzzwords today. Really exciting project. And I have to ask you all, I mean, lots of great comments still coming in. Here's a great comment from Sadna. I can't get over how realistic sim environment looks. I couldn't agree more. Really, it's hard to tell what's real and what's not. Super impressive. Here's another good one. Just came in from a new viewer, I think. Nice job. What can you tell us about the Sim to Real news that will come in the new Isaac Sim Tomorrow update? That is a question for the Isaac team. If you are not a member for the Omniverse Discord server, please go ahead and join. It's discord.gg/NVIDIA Omniverse. And we have an Isaac Sim channel on that Discord server. So you're welcome to post there, and feel free to tag me. And I'll be happy to bring in one of the Isaac developers to get you some information on that. Normally, though, as a general rule, we can't really announce things too much before it's real. So the news will be the announcement itself, but we'll see if we can get you some information. So I have to ask you all. So this seems like a really fun project, not without its challenges, but you accomplished what you set out to do very nicely. So what's next? I know that a couple of you are graduating. Are you still going to be working on with COMET? I know Jack's got a little while to go, but he's almost there. So Jack, well, I guess starting with you. So what's your next project? What's a project kind of in progress for you right now?
Sure. So I've still got school to go through, so I got to get a couple more good grades and then I can get through. But in the meantime, I'm looking to do some work on actually on integrating a robotic system with manufacturing. That's a good job that I've been working on getting into, and that also involves utilizing digital twins to simulate a space, right? Because we can't confirm everything with sensor data, but having a digital twin can give us more information on what's going on in that environment. So using digital twins in conjunction with robotic systems is going to be probably where I go next.
Very cool. That's awesome to see you carrying on the work you've learned here on to other cool, exciting projects. You keep us updated. If you want to come back and give us an update, that would be amazing. Um,
If I get a
uh,
pen, only if I
yeah.
get a pen, I'll come back.
I'm
So
sure we could swing a pen. Amelia, did you hear that? Amelia's listening. We'll make sure we're getting right over to you. Jamari, so what's up next for you?
Yeah, so for the summer, I'll probably be staying here at COMET, developing my manufacturing skills, learning how to use a lot of the cool 3D printers that I haven't been trained on yet. So I'll be doing that as well as doing design research with Professor Schwartz. And after that, I might stay here full time, but I'm also open for new opportunities for the fall as well. So yeah, I'm interested in like the packaging industry and using maybe like human factors and applying anything that I'm learning here to that. Also like the cosmetics field, soft goods as an industrial designer. Yeah.
That's fantastic. Yeah, we have a great industrial designer we've had on before. We'll have to Tanya Langner. We'll have to. I'll link you to a couple of her links a little later. Maybe Amelia, if you want to post some of Tanya's work in the chat. She's got a couple of great live streams she's done with us, showing off her industrial design work. But that's awesome. So everyone heard directly there. If you're looking for this kind of talent, now's the time to grab her. Her LinkedIn profile is in the chat if you scroll up a little bit, or we'll post it again in a minute. Super exciting. I have no doubt that it will be a very short time before you land something pretty amazing. I just really blown away by all the talent each of you have. Speaking of which, Rebecca, you did a lot of really interesting work on this project, and really, really cool to see how you dove into things that were totally new and did not stop you. What are your plans?
So this summer, I'm actually going to be working with the University of Luxembourg. So I'm going to be working with one of their experimental soft matter physics labs over there, which is really exciting. And I'm going to be doing some work with them. And then in the fall, I'm not really sure yet. So I guess we'll see.
Oh, very cool. So another opportunity for those out there looking for some talent. And actually, Rebecca, I think this question goes to you from a little earlier. In case you want to create a sensor, for example, an infrared sensor, how to simulate its behavior, do we have a code to tell its behavior for various data?
Yeah. So in the controller and the Arduino setup, we actually have a setup for a force resistive sensor right now. It wasn't integrated into the final demo, but basically you would have to have that data streaming in as well. And then in the behavior script, that would just have to get applied to some other asset. So that's definitely integrated in there. And I also saw the same person saying that they wanted a complete video tutorial. So we can definitely try to get that done as well to hopefully answer some of those questions too.
That's funny. I was gonna mention that. Let me see where we put that comment. There we go. We'd love to get a complete explained video tutorial if possible. So that would be fantastic. So I'll chat with you all after this. I agree. I think you guys hit several different touch points here from start to finish, weaving in and out of things in a really nicely organized way. I have to give hats off to Matt Schwartz. Matt Schwartz, if you're interested and you want to give a couple of words on your kind of background on the project, feel free to pop your camera on and I'll bring you up in the stream. But keep the questions coming in the chat. This is great to see so many people. Here's another one from, I think, a new viewer. Is it beneficial trying to build this project using OpenMCU? I don't know if anyone can take that one, or if that's unfamiliar. Might need some more context there.
Yeah, I'm not sure I've ever heard of that or used that before.
Yeah, so feel free, Ajay, if I'm pronouncing your name correctly, I hope, feel free to provide more context in the chat. We'll circle back. And then let me see. I think we've got, I'm scrolling through to see if any more questions. I see Amelia posted Tanya's profile page there, so feel free to check out some great industrial design work from her. She also has been diving into Omniverse a lot with her projects, and really cool to see her work in the community challenges we've been doing. Okay, I think we're relatively caught up. It looks like someone's Googling, and so it looks like it's a new area for others too. So really interesting to find out more about that. So Sam, tell me. So you have a lot more people coming in. You're looking for more people to work at the COMET Center. This is pretty exciting though to see a project like this kind of go start to finish and leverage all the different tools, or probably just a fraction of tools you guys have there, but still leveraging all the different tools there, that everyone was able to work in the same place to do that. Must be pretty exciting to see something like this come together.
Yeah, it really is. They mentioned how they had gotten a little bit of preliminary training on working together last summer when we built a hovercraft quadcopter combo that could kind of stay low to the ground and move around and conserve energy, but then hop up in the air in order to get better views and get over obstacles. That was really a foundational lesson in just how do you work with 20 people on one project. This team in particular really embraced what we did last summer, though, and the kind of value that working as a team brings. And they came up with this idea on their own. Now, it plugs nicely into some of the other work we're doing. Jack kind of talked about how we'll be integrating robotics with several of our manufacturing pieces of equipment to kind of try to help realize the promise of 3D printing. Remember 10 years ago when everyone was going to have a Star Trek replicator in their bedroom? Obviously, we're not there, but, if you combine what they did here with industrial scale robotics and some industrial 3D printers and cutting machines, maybe you get a little bit closer. We demonstrated in this project some of the print electronic work with the LPKF, but we also have a Nanodimensions Dragonfly and some end scripts, a pick and place and solder dispensing machine from SM Tech. And so my next challenge to the team actually is I want to build a quadcopter from as low down in the supply chain as possible. We're not going to etch our own semiconductors, but if we can get some bare dies, actually populate flight control board, integrate it in with a 3D printed housing. We've had another mechanical engineer that has printed more propellers than I ever want to see in my life again, but he's been working on actually being able to 3D print propellers. And so, we really try to give interns and people opportunities to plug in wherever it makes sense for them. Rebecca talked about, and Jamari talked about how they didn't really enjoy coding maybe before this. This was the type of project that they could sink their teeth into and really practice. And Jack, he didn't mention this, but he's thinking about going into grad school now after he graduates next year. And so maybe he'll continue doing some materials development with advanced manufacturing. And so, we kind of try to tie into the whole advanced manufacturing ecosystem. And so if you're interested in what the team did here, reach out because we got a lot of other cool stuff going on.
That's so awesome. And I think for those who join us a little later, I'm gonna replay that video, one of the comment centers. We can talk over this. So if this mutes your mic, just unmute your mic when I start playing it, but we can talk over this. But just for everybody to get a really good look at how innovative this center is and how forward thinking a center like this is, and how helpful it is for the developers and the creators of tomorrow, being able to leverage all these different technologies, hardware, software, building space, the collaborative teamwork environment, interdisciplinary, of course, with the people from different backgrounds. Really just fantastic. I mean, this looks like this is like a dream vacation for some engineers I know.
Absolutely. I joke that I try to put together what I wish I had when I was 20. Not that, half of this technology was available when I was 20, but having that hands-on experience so you can kind of go back and forth between the theory you might be learning in college and actually applying it. One thing that the interns did not mention is they actually put this video together. This was for a conference that I went to last December, and we had planned ahead a little bit, captured some kind of B-roll from the previous summer internship, but the team here helped really edit it together and augment additional footage to put this video together. So, we not only work on the developing and the engineering and the science, but also the storytelling and the marketing around what we're doing so that people kind of get a sense of what the whole workflow they're working in is like and can start to gravitate towards what they want to do. Because I'll tell you this, I had no idea that I wanted to do this when I was 18. And so the idea that you're just going to land in the right major and step through methodically. I mean, God bless the people who can work like that, but I can't, and I know a lot of the interns enjoy the opportunity to try new things out.
So amazing, and I saw some familiar faces in that video. Very cool. Yeah, I mean that video looks super professionally produced. So good job on the team. Yeah, very exciting. I think I can't thank you all enough for first of all for being brave and showing your work all the way through. Really cool to be as transparent, not only describing everything, but also making your code available. So everyone watching, that code is available on GitHub, and some will also be added to that over the coming days. So feel free to check the links in the chat, or we'll also add to the description after this live stream ends. But also just coming on here and just going over everything. I think it's so exciting to see this kind of collaborative work come together, especially leveraging some fantastic technologies, including OpenUSD. Let me ask you all a question before we sign out in these last closing minutes. What advice would you have to developers that are just getting started, or say, for example, someone tuned in, they saw this live stream, and you inspired them to start fooling around with a digital twin or a robot arm to maybe tackle a cool problem? What would you say would be a great first steps to get started? We'll start with Jack.
Sure. So these are actually probably in Sam's words, but fail fast and fail hard. Whatever it is you're doing, especially with this type of stuff where there's barriers everywhere, you need to make sure that you're constantly iterating, making sure that whatever you're doing, you fail, you know why, and then you go and fix it. And honestly, that is the loop that has kept us able to produce this project. So I would say fail fast and fail hard.
Very cool. Jamari?
Yeah, so same thing along the lines of what Jack was saying. Just don't be afraid to start. I know like a new software could be very intimidating. It was kind of intimidating for me, but once I got used to it, it was fairly simple and very useful for our project. So just don't be afraid to mess up. Just start messing around, doing things, and see what you can do.
Very cool. Great advice. We'll shift down to Rebecca.
I'd say definitely recreating other people's projects is very helpful. I know for me, just finding random community members who have any sort of information up, I like trying out their projects, and then that leads to a lot of creativity too. So even if it's not exactly what your end goal is, trying something, maybe following some instructions from somebody else, and then messing with it a little bit is definitely great for learning.
That's amazing. And I'm curious also what some of your resources were. We talked about some of the resources you use for Omniverse and OpenUSD, but in general, what other kind of where do you go? What are your watering holes when you go to kind of follow and dig deeper into some of the technology you guys are working at? Do you have any special websites or people you follow?
I know I definitely look around on YouTube all the time, especially if I have questions or I don't understand how to use some software. I definitely look around there. Usually just Googling stuff comes up with people's GitHubs and code and other videos or forums. I feel like I usually just come across them pretty naturally. So.
Cool.
I think I could also say ChatGPT is a great resource for if you have small problems that you can't figure out how to solve, whether it be a programming problem or Omniverse, or even, working with like hands-on electronics. Like there are the resource that it's able to provide you, give you feedback. It might not be the best resource every time, but it can provide you with, troubleshooting quite often.
Amazing. That's great. And it's an amazing resource. People, hopefully everyone here is using it already, but Jamari?
I would say Professor Schwartz was a good resource. He helped out a lot, just understanding the program. And same as Rebecca, just looking up YouTube videos.
He is a wealth of knowledge, that Professor Schwartz you have there. Really fantastic. We'll post a link to that blog on Matthew Schwartz's work on accessibility, leveraging OpenUSD and Omniverse. Really fantastic story. And obviously we have had him as a guest on the live stream when he walked through that even more depth. So we'll post those links in the chat or include them in the description. I couldn't agree with you more, though. And actually, we have in the last couple minutes, we actually have a great kind of way to close out the live stream. And this is basically a good question from Zia. What would version 2 of this project look like? So if you had basically you just finished the first milestone and had the proof of concept kind of working, what would you do as kind of like stretch goal here?
I think I might be able to speak to us a little bit. You know, the original idea was a Zen garden. So getting a little plot of sand, making a little bit of a rake maybe would be the physical. But another addition we could do was to almost maybe break up the controller, the Arduino that the controller runs on, and then that the actual robot runs on. And then we could basically have a link that goes through the digital twin. And the digital twin would be able to tell us if it's about to crash, we can stop the robot as opposed to it going into the wall. These are the types of things that we could add on.
That's amazing. Looks like Rebecca said, do you agree, Rebecca? Is that what you would do? Yeah.
I think so. I think some more like real life feedback into the system would be really interesting, like sensors and, you know, maybe a more constrained environment. That could be really interesting.
Very cool. Yeah, last week we actually had Microsoft on talking about leveraging IoT with digital twins. So I think that's a great idea. I see Amelia is so good. Like I can say anything, and she's got a link in 2 seconds. I should test her one of these live streams. Just throw out some random topics and see how quick she is. But she's already posted the great blog with Professor Matthew Schwartz from NJIT. Okay, we got a great kind of let me see if this is appropriate now. How did they add the reference to the Python script in the USD scene hierarchy?
Okay, so for that, we attached it to our USD file of the robot itself and just added the Python scripting.
There you go. Easy enough.
Yeah, it was pretty easy.
Okay, fantastic. All right. Well, we're just about out of time, and I first of all, again, I can't thank you all enough for spending this hour with us. It went by super quick. Really, I have great hopes for the future now, knowing that developers like you are headed off into the world doing amazing things. I felt like I was at a high level NVIDIA meeting with veteran engineers this whole hour. So really honored to have you join us on the live stream and share your fantastic project. Really timely, really cool that you guys really were able to cover so many different topics here, from OpenUSD and Arduino and Python, digital twins, robots. Really fantastic. And Sam, thank you so much for letting your team come on here and also just telling us about this great program at NJIT with COMET. It just seems fantastic, and it seems like something that should be happening everywhere in the world. Really innovative, very collaborative. It must be such a fun place to go to work every day. Maybe if I can get down there, I can come and check out firsthand. That would be a really big treat. Everyone who joined us, there's hundreds of people watching right now. Thank you so much for joining. Your participation in the live chat and viewing is what makes these all the more fun. If you've liked and enjoyed this, please don't forget to like and subscribe. It really helps others discover this. Also lets us know what content people really like. And of course, you'll be notified when we have the upcoming live streams. Next week is also a very fun one with Aaron Luke. We're going to be doing OpenUSD, kind of like a full overview. So for people there who just want to start diving in with one of the premier experts in OpenUSD, next week is going to be the great place to find out and ask your questions, whether you're new to it or you're a veteran. So we'll have that link up on EdEvent. Actually, it's up there already. So if you go to our EdEvent calendar, you can add it to your own calendar very easily. Thank you, all of you, for joining us today. A huge pleasure. I'm going to play that video one more time so people can kind of see the final work you guys did. And here we go. Just really wow. There you see. Amazing. Let's spill the beans. There it comes. Spill the ABS beans. Very cool.
Well,
Amazing.
thank you. And anytime you can make it up here, the door is open. We had a great time and really appreciate the opportunity to show off the cool work.
It was my pleasure, and I wish you all great success. You need to wish you any luck, because you don't need it. You guys are ready to go. Jack, good luck on the next few months. I have no doubt you're going to have a great time, and we're going to keep in touch and hear what you do next.
Sounds great. Thanks, Edmar. I appreciate it.
Of course. Okay. Thanks everybody for watching. We'll see you next week when we dive into OpenUSD with a nice overview with Luke. Bye, everybody.
All right, bye everyone.